Hi everyone, in this video we are going to try to answer the question, is the water safe to drink? So we know what happens when we dissolve something like sodium chloride or potassium chloride in water. We know how the ionic compound dissociates, and then it's able to actually form these ion-dipole interactions between the cation, anion, and the actual water molecules. So we know what happens when something like a salt dissolves in there. But what happens when something like lead or mercury actually gets into our water and then a human drinks it? Well, it's not good, I'll tell you that right away. And so what happened is a long time ago, so back in the 1970s, a bunch of different standards were created, just like we did with the Clean Air Act to try to guarantee our safety with our air pollution. We also did the same thing with our water pollution to try to make sure that as humans drink the water, it's always safe. And so two major things you need to kind of know here in order to even address the next section of this video. The first thing is we have these things called maximum containment level goals. Okay, so we have these goals, and so usually people just refer to them as MCLG. Okay, maximum containment level goals. That says MCLG. Sorry, it's a little messy. So the long definition for this is the maximum level of containment in drinking water that does not affect human health. Okay, so we want to know, what is the maximum amount of mercury or the maximum amount of lead that I can physically drink before it starts taking a toll on my health and actually starting to deteriorating my health, right? That's the goal. So this is the maximum level before it can affect the human health. Now, we also have something that is not a goal, which is just your maximum containment level. Okay, so you just drop off the word goal. And so these are usually referred to as MCLs, so maximum containment levels. So your MCLs is the legal limit. The legal limit for contaminants. So this is something that a big plant or factory would be very much interested in, because they want to know exactly how much of whatever contaminant they have they can dump in the water before just dumping it back into lakes and rivers. So they want to know legally how much can they contaminate the water, where the rest of us usually want to know the goal, because we want to make sure that we are 100% minimizing any time or any exposure we have to lead, mercury, and the such. We want to avoid it. It's really bad for you. So usually, not always, but usually, the maximum containment level goal is equal to the maximum containment level. Usually. Not always, which is a good thing, right? We want to make sure that we aren't having a legal limit that is higher than our actual goal that would start affecting our health. So that would be a bad thing. Now, the exceptions are carcinogens. Carcinogens. So carcinogens, if you're not familiar with this word, are essentially just molecules that are known to cause cancer. So molecules that cause cancer. And so now whenever you have a carcinogen, they always have your maximum containment level goal be equal to 0. Okay, so if it's a carcinogen, for example, lead or something like that, that's going to be really, really bad for you, they always make the goal equal to 0. So they just say you don't want to be exposed to it, you want to limit every single drop, you want to make sure there's no way you're ingesting any bit of this lead or mercury into your body, okay, so anything that's that bad. So let's show us a little table here. And so the first thing I want to point out is that for almost everything, okay, except for lead, I keep coming back and using lead as my example, but for almost everything, our goal and our actual limits are the exact same value. So column 2 and 3 are equal. So for cadmium, it's 0.005 ppm for both the goal and the legal limit. Now, the one we look at for lead, we see that the goal is actually 0. We're saying we do not want to be exposed to lead at all for our goal, but legally, we could technically be exposed to 0.015 ppm. Now, I do want to point out that this is in ppm, parts per million. So we're saying that for these goals, I mean, this is how much cadmium is going to take to actually start affecting us. 0.005 ppm. That's 5 ppb. That's a teeny tiny amount of this cadmium actually starts to take a toll on our human health. So that's really bad. So before I go on and talk about the actual legislator and the effects of ingesting all this stuff, I want to ask you a quick question. Of the ones listed here, which contaminant is the human body most sensitive to. Okay, so just looking at this chart alone, and go ahead and ignore this last one just because we don't have a layer here. It says vary, so just go ahead and ignore the last one. But which contaminant is the human body most sensitive to? Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. All I wanted you to do was look at this table and try to find the smallest number. And so what I see right away is that when I look at mercury 2+, or the mercury cation, I see that we have a sensitivity of 0.002 ppm. That's 2 ppb. So our human body is incredibly sensitive to mercury, and especially mercury 2+. And so if you are exposed to a lot of mercury, so those of you who eat a lot of shellfish or sushi, that's something you definitely need to be aware of. Or if you're pregnant, you need to be aware of this too. But so mercury 2+ causes severe neurological damage. And so your brain, your kidney, your lungs, your heart, all of them can be severely damaged if you have too much mercury or you build up a certain level of mercury in your body. All right, so now let's talk about a couple other symptoms. So lead we said was a carcinogen. Lead is something that causes severe neurological problems, just like mercury, but it's actually a little bit worse. And so one of the major symptoms of lead poisoning is very much sleeplessness. So people cannot sleep at night. But the big one is irrational behavior. And so if you have a friend that starts acting like a complete loon, just very kooky, and they're doing things that are completely out of character, you should say, hey, have you been drinking some weird stuff? Like, do we need to get you tested for lead poisoning? Because usually that's one of the greatest symptoms of it, is that very irrational behavior. It just doesn't make sense what they're doing. The next one I want to talk about are nitrates. Nitrates are something that are really bad if you get it in your system because it ends up limiting your body's ability to carry oxygen through your system. And so it's a problem for us, but as you can see, it's one of the things we're least sensitive to, but it's really a big, big problem in babies and infants. So anything that's really, really tiny, they can build up this nitrate intolerance so quickly, and then all of a sudden their organs and their vital pieces are no longer getting oxygen, especially their brain. It's really sad, so you have to be careful. The last one I want to talk about is bacteria. So if any of you have ever traveled to Mexico or heard of something called Montezuma's Revenge, it essentially is just when water has certain bacteria in it that certain people might not necessarily have the immune system built up for. So people who were born in Mexico and born in these certain cities often have a complete tolerance for it. They can drink the water with no problem. But I know me personally, if I were to go to Mexico, which I love to, I got married in Mexico, I'm a big fan of it, but if I were to go there and drink the water, my body would be sensitive to the bacteria in it, and it just doesn't handle well. And so usually what happens, if you ever heard of Montezuma's Revenge, is usually you have horrible stomach cramps followed by diarrhea and vomiting. So it's not good. I actually had a girlfriend of mine get Montezuma's Revenge on our honeymoon. So it's like the worst time to get it. I felt so bad for her. All right, moving on. So the last thing I want to point out is that there's two major laws you need to be familiar with when we talk about drinking water and safe water. And so the first one should sound really familiar because we've talked about the Clean Air Act when we talked about the air we breathe. Now we're going to talk about the Clean Water Act because now we're talking about the water we drink. So the Clean Water Act was established in 1972, and it is our primary U.S. law that governs water pollution. Okay, and this actually was one of our very first environmental laws that was established here in the United States, and it was actually something that was very, very well received. Obviously, everybody needs water. We need to make sure we're drinking clean water. But it was a major one that addressed pollution, okay? But it was pollution of surface water. So it was limited to that very top surface water, if you remember when we talked about all the difference between surface and groundwater. So it was limited to the top. So basically what it did is it addressed companies or factories that have water waste, and they addressed where they were dumping it and their contaminant levels. And so they were very, very clear about this, that you had to protect our lakes and our rivers, but it was surface water only. So then what happened is to follow that up, we came up with I wasn't alive then, but we came up with the Safe Drinking Water Act. Safe Drinking Water Act, and this was established in 1974. So now this one is the U.S. law to ensure safe drinking water for the public. For the public. It seems really straightforward, nothing fancy about this, except for the fact that instead of the Clean Water Act only including surface water, we've added this second act to include groundwater. So to make sure all of our aquifers are protected as well, because we want to make sure if we contaminate something and then it gets into our groundwater, then it contaminates our well, it's a really, really, really big problem. And so this was something that was super important because we were able to include groundwater. But the second thing I want to talk about is that it actually forced the EPA, so the Environmental Protection Agency, it forced them to establish standards. Okay, safe standards. And so this is the important part. So just like before when we talked about the air we breathe and the Clean Air Act, we had all of these air quality standards that were very, very important, and we wanted to make sure that every single company, everybody was abiding to these laws. Same exact thing here with water. So instead of just pumping emissions out into the atmosphere, at this time we're talking about you can't just dump your waste into water that humans, especially American humans, are going to be drinking. And so these are our two main rules that protect our drinking water, and both of them were actually really well received by the public because we wanted to make sure our water was good. So it was a wonderful, wonderful time for the U.S. here in terms of our laws. All right, quick question here. If you have 15 milligrams of lead in 1 liter of water, are you, or is the glass above or below the MCLG for lead? Okay, we're talking about the goal specifically. Go. All right, did you get an answer? Hopefully you did, and all you had to do was determine your new concentration of lead. So we said that we have 15 milligrams in 1 liter of water, and so if you determine your concentration, you would see that this is equivalent to 15 ppm. Now, I asked you about your maximum containment level goal of lead, which is equal to 0 ppm. 15 is definitely higher than that, but if I just asked you for your maximum containment level, so the legal limit, that's at 0.015 ppm. So regardless, no matter which one I asked you, are you above or below, you are definitely above the limit. You do not want to drink that water. I'm going to leave you with that. Take care of yourself. Drink safe, non-contaminated water.